going. So this week, we're going to talk a lot about sets. In the book, I think they called it set theory. And when we think of a set, they kind of, sometimes I think the words, the vocabulary gets a little confusing. So I'm going to try and explain it in a very simple way. And maybe the book I actually thought did a pretty good job. The only thing that I think got a little confusing is it used the Venn diagram again, and they used it horizontally, which we'll talk about that in just a minute. Because in the past we've done joins, right, where we take two tables and we can join them together, kind of glue them together and match the rows up between them. And I like to describe that as horizontal because we're adding columns, we're not adding rows. Now, based on our joins, we can filter rows out depending on the kind of join. But for the most part, the reason we're doing a join is to add more columns, which is a horizontal operation. So just a real quick review, I wanted to show you one of those. So let's get all the movies and the actors in those movies. So we're going to select the film.title, the actor.first name, and the actor.last name. We're going to get that from film F for our alias. We're going to interjoin that with film actor FA on F.film ID equals FA.film ID. And then we're going to interjoin that with actor. Oh, and I guess I should spell join, right? Interjoin that with actor A on FA.actor ID is equal to A.actor ID. All right, and now we should have all the data we need. So we're going to run this up, and I need to use Sakila. All right, so now what we'll get is we'll get a result set with the title of the movie and the actor that's in it. And we can see that there's actors that are in many movies, just like we would kind of see in real life. So that is a join, and you can see that basically what we did is we were able to add columns. So film originally had title, and we wanted to add some columns from actor. So we glued those fields from actor on the side. And really, if we were to select everything, if we just said, let's select everything from the result of this join, we get all of actor attached to all of film. So here is the end of film, and then we have a film actor, and then we have actor. So we actually get all three tables glued horizontally together. Now, what we're going to talk about this week is set theory, and set theory deals with vertical joins. So, for example, let's say we wanted a list of, we're going to do a real simple one. Let's say we wanted a list of movies that are rated G. So we're going to select title from film where rating is equal to G. All right, pretty simple. We've done that before. We can even, let's get the rating in here too, so we can make sure that we're right. All right, so there's our rating. We have the title, the rating, and they're all rated G. Now, what if we want to add to this list, right? Now, normally what we could do is, we could say a lot of times, like we've done in the past, we can say rating is in G and PG. If we were looking for clumps of movies, we can use where filters for that. But sometimes we either can't use a specific filter, or we're pulling from multiple tables, even though it's the same data. You can imagine if we want everybody's name, whether they're an actor or in fact, that might be a great example. Let's take a look at our customer table here. So let's say describe customer. Let's take a look there. All right, so you'll notice we have first name and last name, and let's describe actor. Let's see what we got there. And we have last name and first name. So let's say we want our customers and our actors all in the same list. Because let's say we're just going through and we want, say, oh, we're trying to pick a baby name, right? And we want to go through a list of names. So we want the last name and first name. So let's write select last name. Let's select first name, then last name. First name, last name from actor. So we get that from actor. And we have first name and last name. If we were to do a join, we wouldn't have anything to join on because there's no common denominator between actor and customer. And we would just get actor last name and actor first name over here on the side, which is not what we want. We just want a longer list, right? We want to add to the bottom because right now we have 200 names. We want all of our customer names added to this list. And that's where set theory comes from. So now we're going to say union select first name. First name, last name. Wow, and it keeps trying to autocomplete for me. From customer. Now, if we do this, we are going to get a bunch more names. And so union will let us add them. Now, union also, if you've already read the chapter, there's kind of two options with union. We have union and we have union all. And typically, it just depends on what you're trying to do. So if we have a plain union, it's the same thing as doing select distinct. So let's say that there's two Nick Wahlbergs. It's actually going to filter them out because let's say Nick Wahlberg is actually a customer. If Nick Wahlberg is both an actor and a customer, we're only going to see Nick Wahlberg listed once. So in the case that we are trying to find, we just want a list of all the names because we're trying to find a good baby name. Union will work fine. But if we are trying to just get a list of all of our people, maybe we want a union all. Maybe we're looking at everybody uniquely. Like maybe we have a person ID in there somewhere. So then we would want a union all. And in that case, we would see Nick Wahlberg twice. Now, I don't think there's going to be any of those, but if that were the case, we could do that. So you can see what we're doing here is we actually have two different select statements. And that's why it's called set theory, because this is a set. The result set is what they're referring to. So this first query is a result set, and the second query is a result set. And we're merging those together just like we did with our Venn diagrams for our joins, but instead of it being side to side with columns, now we're just adding to a list. Now, one thing to be aware of is that if, let's say I add another field here, let's say I add email to this list, you'll notice that I get an error and it says the use select statements have different number of columns. So they have to have the same number of columns and those columns have to be the same data type. So if I add actor ID here, you can see that it's going to make that actor ID become an alpha character instead, because it basically has to be able to hold all the data. So even though in some cases we have a number for the ID and down here we have an email, it's going to go with the one that will hold them both. And so like if we had a date and names, and typically you wouldn't want to do that, but it is possible. So for the sake of just being able to show something here, I'm going to say, let's customer as table. And let's do actor as table. There we go. Let's see what we did here. Make sure I have space as I up my text size so we could see. Let me just try that again. No. No. There we go. Oh, table is a keyword. Let's do as source. There we go. So now we can see which table the record came from. So we can see all of our customers and all of our actors. All right, and then from there we could sort it. So if we say order by, let's just sort by last name and then first name. And there we go. So you can see them all jumbled up there together. So that's a union and union all. And really the concept's the same. Now let's say that we want to see if there's any common people between these. And that's where the intersect comes in, because we can see if there's any common denominators. And let's see what we did.
Intersect can't be used in MySQL.
Oh, that's right. Sorry, I get so confused because I use a SQL Server all day. And so let's see what is
intersect and except, neither one can be used.
Yeah. Operators. I get really confused between the two. So let's see, we have a union. What is it called in MySQL?
An inner join or?
Oh, hold on. I'm trying to, where's my book here? Because I also wanted to show these Venn diagrams. Apparently I still haven't put that book on. Let's go. It's in the PowerPoint. I'll pull up the PowerPoint real quick.
So Christian told me that when I'm trying to do an intersect operator, to use inner join, and when I'm trying to do an except operator, to use a left or right join. I don't know if that's what you're trying to.
Yeah, it's kind of, let's see here. Oh, I'm in the wrong one here. Sorry, give me just a second. I clicked on the wrong module. Week 5, there we go. All right. So we have union, intersect, and except. Now, MySQL has some limitations, I guess you could say. But it's important to know what we're doing, because we have to know this stuff. So let's start with the union, which we just looked at. And there's our stuff. All right, so when we did our union, if we're looking at our Venn diagram here, a union has, and I like to actually face these the other way. So I actually like to rotate this just because mentally it helps me. So I like to picture that A is vertically stacked on top of B table or set B. So in our example here, actor would be A, and our query that pulls from customer would be B. So from there, what we want to do is we would overlap those two. And when we do our union all, that's what we get here with the full thing. When we do a union, we get everything, but it's condensed down to unique variables. So it's not necessarily the middle like a lot of people like to think, because we do get everything, whether it's from B or A, because we're not matching. And I guess that's the biggest thing to remember when we're talking about union and these vertical operations. We're not matching on any data. We're simply adding to a list. And so if we look at some of these other ones, so an intersect would be if we want to see what the middle is. The middle what would be in common. So like in this example, if we wanted to see what we have for, what if there's anyone who's an actor and a customer, we would run intersect. Now an intersect in MySQL isn't possible, but let me see if I have a good example I could give you. I don't know if I have any that would be okay. Yeah, I'm not sure if I have any, but an intersect would be if we want to see what's in the middle. So here's a good example. Let's say that I'm a DBA at the school at BYU, Idaho, and I want to know which students have taken CIT 225 and CIT 111. I could use the same query and I could say, something along the lines of, I could write my two queries, select everything from, let's just say person, where taken, and obviously it would be more than this, where course taken equals CIT 225. So that would be our people who've taken CIT 225, and then we could intersect and see the people who have taken CIT 230. And the join of that would be the list between intersect would be a comprehensive list of students who have taken both CIT 225 and CIT 230, because we get where they intersect. And it is kind of like an inner join in the sense of you're getting where the matches are, but that's the big difference is we're matching based on, with the intersect, we're matching based on if they exist in both queries. But as far as the union and the minus, it's a little bit different. And that's where we're going to get, well, I guess with except. In some it's called except, in some it's called minus. But if we want to see everyone who has taken 225 that has not taken CIT 230, we would use except, which would get us everyone from the first except those on the other side. All right, and they give you some good examples in the book. Let's see if there's the union. Okay. And so that's where they talk about MySQL. And that's one of my biggest things with some with MySQL is it's purposely held back, which can sometimes be not so much fun. Which is why many times I like, that's why my preference is Postgres. And I'm going to see real quick if I have something here that we could use. Let's see what we got here, because I'd really like to show you one of these. Let's open up a new one here. Let's take a look here. All right, there we go. So this is these are actually cows. And let's say we want to find what's a good one we can match on? Let's take a look at I just don't have enough tables. Because most of the time when you're using these operators, you kind of want to have multiple tables that have the same kind of information. Like, for example, in our case, we have two names, or if we had two numbers or something like that, that's what kind of where we'd want to be. And I don't know if I have a good example. So let's see if we can find one. Three schools. Union. Let's see if they have. There's our union. Do they have? And is anyone still shaky on those, or am I just going to cover something that everyone's got figured out? Yeah, maybe they don't have one. So the book might be the best resource on that until we, I'll see if I can get some examples built, because I do have some in another database. I just can't query it without making sure there's no sensitive data in it. So it doesn't sound like anyone's too fuzzy, but one thing I wanted to talk about, because it sounds like the TA said you could use a join, which in some cases is possible, and in some cases is not. You kind of have to cheat the system just a little bit. So if we were gonna do this again, so we have our select first name, last name, actor as source. From actor, well, it's yeah. So we have our example here, and we wanted to see if we had any who were both. We want to see if we have any actors who are also customers. And normally you can see how much easier this would be, because in other databases we could just say INERSECT and run this and it would work. But in MySQL we kind of have to do a workaround in the sense that we have to turn these into temporary tables. So let's call this tact, and we will call this one tcustomer. So if we want to see where these intersect, we would have to do an inner join now, because essentially we're going to treat both of these like temporary tables. So we're going to select everything from that, inner join that on the first name and last name. And like I said, this is where it gets a little bit weird. It's just definitely not as clean. T custom. Oh, so we do actually have someone who matches. What do you know? But you can see how to get the same results, we have to kind of do this and match based on that data. Now the union works because the union just adds to a list. This way it does it. And you'll also notice that instead of actually getting a list, we still end up with this same result. So we're not adding down like the normal intersect would. We get this because normally if we did an intersect, we would actually see actor and customer both there. And then for our, oh, go ahead.
Oh, I was just gonna say, the one thing as you're going through this that I thought of is it would help if on the questions, they told us how many columns we were looking for, because on last week's homework assignment, I spent hours trying to figure that thing out and trying to get it down to just the 4, and I could never figure it out. And then the answer was really 8. And so I guess it would help if we knew how many columns of information we're supposed to have at the end of the question, you know, when we're doing queries and stuff.
Gotcha. How many rows or rows, right? Not columns.
Rows.
Gotcha. Okay. Yeah, I'll take a look at those. All right. So there is our intersect. And so if we wanted to see except, like we've done in the past, we would change that to a left join, keep our on stuff, but then we would just add a where clause and say where tcust dot, and this is where we just got to pick one. Last name is null. So if we want to see everyone in actor that's not in customer, we can do that. And again, it's not quite the same thing because you'll notice we get kind of some weird stuff going on, which is why I like those the set theory operators. But this way works too if you're in a pinch. So yeah, they're not too crazy because really your sets, it's just about getting the information you want. In fact, I actually had to do kind of something similar to this today, where I needed to know, which students have parents had opted to be whitelisted, meaning that their devices are locked down to my coworker who is a sysadmin. He's like, I need to know which students are whitelisted, meaning they can't have any extra apps on their student device and all that kind of stuff. And also if they are in this specific course, so we can give them a specific app. Because if they normally students can just download the apps themselves through our little self-service store, but if they're whitelisted, they don't have it. So he needed a list of everyone that he needed to manually install this application on their device for. So I actually had to do that. I used an INERSECT. I just wrote 2 select statements because I wrote everyone who was whitelisted, and then I wrote everyone who was in the course, did an INERSECT, and got them that result really fast. Which is really nice. So it's something that you're going to come across a lot if you're doing it, and having those commands, the union, the intersect, and the except really make a big difference. So does anyone have any questions? Like I said, this week is pretty light, so I didn't want to take up too much time. Because normally we go on for hours and hours, but I also don't want to cut you short of anything. So if you have a question, feel free to ask, or if there's something that's been foggy from previous weeks, we could cover that too.
I think where I get lost is like in last week's exam questions or quiz questions. Just trying to parse out everything. So it was the Harry Potter prequel ones that they were.
Yeah.
That really lost me. Like I couldn't even figure out what it was saying. It just completely lost me. So
yeah. And we've had some discussion about that, which is why week 4 is also going to be like week 3, where you're going to get full points for it. Basically, when I go through and grade it, it's pretty very lenient, which is actually how the exercises are kind of. I don't know if you guys have noticed, most of the time, unless something's way off left field, I give you the points, but I'll put a comment saying like, hey, just watch for this, like, and maybe explain some things. So you don't need to worry about your points necessarily, but
right.
as far as understanding it,
and how the query is built, and then how to interpret the query.
Yeah, let's go.
Because I'm such a visual person that if I can't see it, it's really hard for me to make sense of what I'm looking at.
Yeah.
So I'm trying to figure out how to understand what I'm looking at when I can't see it, because obviously that will be the case in the future too. So
yep. And so let's see. Oh wait, and it was the quiz, right? Not the exercises. Sorry. Let's go back here. Week 4 quiz. Yeah, and I don't know if you guys have seen my post on Teams, because I got a lot of questions about it. So I wrote a nice little nice little post about it, because this is probably one of the more complex concepts. The idea between understanding joins and the outcome. Because really there was a lot of extra stuff thrown in here. A lot of extra stuff thrown in here that isn't necessarily meant to confuse you, because I think they just put a query in there. But the nice thing is we really just need to focus on the from clause and the where clause, and we'll do it. So let me go over some of these quiz questions. So full join. So this is one that we can test, a full join, and this is one of those questions where we're like, this isn't in the reading. We don't cover ANSI 92 and the difference between ANSI 92 and ANSI 89. So but I do want to show you real quick, just so you know, because I do think it's important, even though it's not in the book. So we're going to cover this one real quick. So way back before we are modern day SQL, there's actually two different ways to do a join. So and some of you may have already seen this already. So let's take a look at this join right here. So we want to get all of our actors and what film they're in. So we used an inner join in that example, but maybe we want to, let me get my film.title here, a.first name and a.last name. So we're going to get that. So back in the old days, you used to just kind of separate things with commas. So like, let's just start with film actor FA. So let's actually take our last name first off here. Let's just get that, and then FA.actor ID. So if I were to run this, what this actually is it's actually the Cartesian product, which is a cross join in ANSI 92. So we're going to do an ANSI 89 example here. So in the old days, this is how we got a cross join. And I'm going to try to explain it in a way that it makes sense as if you were doing all the steps. Because from the computer standpoint, what we're doing here is we are getting everything from film, and we're getting everything from film actor, and we're going to multiply that together, because we haven't said how we're going to match. So it just says, hey, for every Muppets Christmas movie there's going to be every actor. So it's like every actor was in every film. And so we get all the possible combinations. Then what we do to get our actual desired output, where we want to see what actors are in what film, we use the where clause. And so we say where, and this is where we kind of set our join parameters, or in this case, where we filter down the rows that we don't want to see, the non-true rows, because we know that there's certain movies that certain actors are in, but we have every possible combination. So what we want to do is we want to take away all the non-true ones. So we say where film ID is equal to the film actor dot film ID. So just like we joined up here, the only difference is we're doing this one in the where clause. So you'll notice on this that I'm clear up to like over 2,000 rows. Well, when I run this now, maybe I'm still going to have a lot. We're still going to have a lot apparently, but we're going to have less, because what we've done is we've filtered them down, and we can check that. We can say right now we have f.title. We can say f.film ID and fa.film ID. In fact, let's just do that because that'll make more sense. So we can see that we're getting at least matches now. You know, Atlantis Cause is film 43. Now what we're going to do is now we're going to add that extra piece, because we can see that there's a, so we're going to just add another comma, and we're going to say actor A. And in this case, we're going to get even more results. And let's go ahead and add let's go fa.actor ID so we can make sure we're matching here. Which this is, by the way, one of those things that you can do to verify your results. Because it's really handy, because then we can see if it where it matches. So now you'll notice we still have film ID matching, but our actor ID has every possible combination again, because we filtered out all the extras between film and film actor. So now we need to filter out between film actor and actor. We only want the records that are true. So now all of a sudden we actually have the same results that we wanted. Now all we see is the IDs, but at this point now we could go ahead and add our A dot first name and A dot last name. And now at this point we actually have the same result set that we got using ANSI 92. So basically, when we're talking about the old ANSI 89, we're using commas or full join, something like that, similar. And basically, what we're doing is we are taking every possible combination, and then we're going to use a where clause to whittle it out. Now, the reason why they made the change isn't just because it's funner to type in or join; it's because it's more efficient. Because in this case, we are multiplying every table by the other. So if we have 100 records in film, 100 records in film actor, and 100 records in actor, it's 100 times 100 times 100 to be your total amount of rows. And the computer has to hold all that in memory all through the where clause. But when we do it this way, it's more efficient because as it's loading those various things, it checks for matches right then, so it can reduce the amount of records that it has to handle before it even gets to the where clause. So that's the difference between ANSI 92 and ANSI 89. Is ANSI 89, you had to specify the commas. Now, back to this question on hand. With this full join is wasn't covered, but just so you know, it is the same thing as a cross join. So even if you knew that, you might click a cross join. But the cross join, if we take a look, we know it's multiplying. So in this case, we would get every customer with every possible address. And the cross join does not support the on clause. So really, the correct answer here is an unsupported join type. Kind of a tricky one. Most of it, all of it wasn't covered in the book. So that's why this is the first time this course has been live. So I do apologize, but we are working through it and it's going to be equitable, but I also want to make sure that I explain it a little bit. So that's where it's coming from there. It's unsupported join type. All right. And question number 2, this is where we're going to start getting more into, I think the real questions you had. So if we're taking a look at these Harry Potter series, and like you said, you're kind of visual. So I actually like to draw pictures. And let me actually see if we can get one drawing here. Let's go here. Does anyone know a good draw? Tell you what, I'll just draw it right over it with Zoom, because I'm a very visual person myself, so I like to draw my Venn diagrams. So what I'm going to do is I'm going to annotate, and we are going to draw a line. All right, so we have our and in this case we're still going to deal with film, so let's draw our Venn diagram. Well, that is not what I wanted. Draw a solid line. Let's try this. There we go, nice and blue. So there's our first table and there's our second table. So I'm sorry, so I'm going to call this one F and this one FP for its aliases. And if you notice from this, they're actually both film, right? We have film here, film here. The only difference is we're giving them aliases, and FP is going to basically be the prequel of the film, or that's kind of the intended purpose. And we're gonna try this out and see what we get. So So let's take a look at this. Let me undo those two circles. And we're doing a left join. And so immediately we know we're getting everything from film or from F, whether or not it has a match in FP. So let's take a look at this. So they're both film. Keep that in mind. And film has a record called prequel ID, which is basically, oh, this is the prequel to whatever film this is. So let's take an example here for a minute. Let's say Harry Potter. Let's use Sorcerer's Stone. Stone. And then we're going to use Chamber of Secrets. Chamber of Secrets. And we know that Chamber of Secrets has a prequel. And so its prequel ID is going to point to the Sorcerer's Stone, right? So we're going to use that example to kind of go through this. So let's take a look here. Oh, and let's add one more. Actually, no, we don't, because we have Sorcerer's Stone. Okay, so we have Sorcerer's Stone and Chamber of Secrets in there. So we're going to check. We're going to do our join. And we're doing it where the prequel ID of F is equal to or match on the film ID of the prequel. So in this case, we're going to get both of these in our left join because this is our film prequel. So based on that match, the Sorcerer's Stone, and it has a match with film prequel. So it's going to be in there. And I guess we should examine the question. It says it returns only films with prequels in the Harry Potter series. So let's take a look at this. So where F.series name is equal to Harry Potter. Well, Sorcerer's Stone would have a series name of Harry Potter, and Chamber of Secrets would have a series name of Harry Potter. And this is where people really start to get messed up just a little bit, because here's the deal, right? Typically, when we use a left join, we want everything, whether or not it has a prequel. So let's say we're also, let's say another movie. What's one that is inside the Magical Beasts? That's in the Harry Potter series, I guess you could say. Because really what we're, and this one makes sense, because really, like if you said, oh, I want all the Harry Potter movies and their prequels. Typically when you use a left join, you want all the movies, whether or not they have a join in the other side, which would make sense because in this case, we want all the films that have Harry Potter and and we want those prequels to be in Harry Potter. Now it's assumed that if it's a prequel, it's in the same series. And where we really kind of get messed up here is on this line right here. This is the key point, because the answer to this is actually true, even though it's a left join. Because usually when we see left join, it doesn't have to be in the series. If we had Shrek here, even if it didn't have a prequel or not, with a left join, it would show up. But because we're filtering this, Shrek wouldn't show up even if we're using a left join, because it wouldn't have a match over here. So for example, let me see if I can give you a quick example here. Let's clear all drawings. And
my thought process is because we were identifying Harry Potter specifically, that it would only give me back Harry Potter specifically.
Yeah. And so like, let's say that I want, let's see, what's a good example here? Let's see who's someone. So let's say we want to find customers. Let's describe rental. Let's make sure that there's a customer ID in there. Perfect. All right, let's say we wanted to find all the customers who didn't rent, who haven't rented a movie. If we want to define that, we would left join on rental on, give these some aliases. So if we wanted to find everyone who had not, or who had not rented a movie, we would say left join on rental R, or rather, if we wanted to see everybody, whether or not they had rented a movie, we would do this. Now we can actually get, let's get the customer ID. Sorry, I'm going to start that over because I confused myself. We want all the customers, whether or not they have rented a movie. Which is typically what the left join is for. Now, in this case, we're just looking at the IDs. So we have all these customer IDs and we have all their rental IDs, and we can see that there's not any empty ones so far. Maybe there aren't any empty ones in general, but we're going to make one. So let's select everything from customer. I'm going to make myself a customer here really fast so we can do a quick thing here. So I'm going to say insert into customer. We're going to insert store ID, first name, last name, email. Do I need an address ID? Let's see. Address ID is, let's try without it. We're going to use store ID 1. Oh, and apparently we need an address ID. So let's borrow someone's address. We're going to steal number 5. So apparently we have to have an address. There we go. So now I should be in there. But I haven't rented a movie. We know that because I just put myself in there. So if we were to run this, we're going to get everybody, whether or not they have rented a movie. But let's make one little change here. We're going to say where C dot last name, like %C or C%. We're going to see all the people's name who starts with a C. And let's actually pull some info here. C dot first name and C dot last name. All right, so down here at the bottom somewhere, wherever I am, order by C dot last name. All right, let's see if we can find me here. There I am. So now we can see me here. So if I wanted to see every movie, whether or not they didn't have a rental, we have succeeded. But the question was, would they show up? So we're going to add this one line that I had highlighted here, this one. You'll notice that this one comes from the other half of the join, which if we remember our little circle, it's the one that if it didn't have a match, it's not going to be returned. And we can see here that even though it had a match, I still have empty values there. So if it has empty values, the series name should be null. It's just like me doing this. If I were to say, oh, we're looking for it here, but we also want to say, and r.rental ID. Anything from that table is going to be null. So we're just going to simulate that by saying is not null. All of a sudden, I'm not going to show up here anymore. Wow, there's a lot of those. There we go. So you can see I'm not in the list. That's because everything from rental, anything on the right-hand side of a left join is going to be null if they don't match. So in this case, let's just select everything from here. So the minute that I put a, you'll see all these have stuff. The minute that I have anything from rental, it is going to be null. So if I said, oh, I want, imagine, because this is the film and this is the prequel. For any movie that doesn't have a prequel, it's going to be all null. So when we put a filter in the where clause, we effectively filter out all of the non-matches, which is basically the same thing as an inner join at that point. So if this is basically what it's asking, it returns only films with prequels. It's asking, is this an inner join? Even though it has a left join, it technically becomes an inner join because of this filter. Does that kind of make sense?
Yes and no.
Yeah, sorry, we kind of went about that around.
Wrap my mind around it.
Yeah, it's kind of difficult because really, you know, let me try to, I guess, full circle this without all this extra. So if we do a left join, and any left join, and it doesn't matter what join it is. So like if we do a left join, the most of the time we're doing a left join to find everybody from the left, whether or not they have something from the right table. So we want all the customers, whether or not they have a rental, or to put it together, we want all the films, whether or not they have a prequel. And that's the purpose of the left join. Everything from the left, meaning from whatever comes before it, we want whether or not that it actually matches. Because I don't have a match in rental because I've never rented one. But because of that, at this point, everything for the rest of that row, anything for any rental column or from the right side of the right side table is going to be null. So in this case, film prequel. So if we put a filter on film prequel or whatever's on the right-hand side, it's going to become an inner join because at that point, if we filter on something there that's not null, it's going to become an inner join because if there's something there, then it matched, if that kind of makes sense. So like this kind of is a tricky one because and I guess the purpose of this is to really, I think these questions come from like probably some like, oh, let's see how much you know. Because this really is, why would you do a left join and then filter on that? Because in the end, you might as well just do an inner join, if that makes sense. Because this will either have something or it'll be, if it was an inner join, we could do this just fine. But if it's a left join, the minute we do this, it takes out all the non-matches and it becomes an inner join. So the left join is completely irrelevant in this case, and we could just say inner join there. All right, and let's move on because I think maybe this will help just a little bit more as we keep going. So this one returns only films with prequels and films without prequels. And this one is one of those verbiage things because, like, to me, this only should be taken out. It returns films with prequels and films without prequels. So that's how I would read that. It returns films with prequels and films without prequels. So basically what it's doing is it's returning all films, whether or not it has a prequel, which in this case, if we took this out, would be true. A left join, just like we did with the customers. We want everything. We want all of our customers, whether or not they've rented something. A left join with one on clause will suffice, right? Now, in this case, we're doing something a little different. So we're gonna try to draw here just a little bit again. Because if we take a look here, we're doing a right join this time, which again is kind of there to kind of trick us up. So we're gonna call this one F again. We're gonna call this one our prequel. Now, in most of these cases, the on condition is completely right. This one's a little different. So we'd say from film F, and we right join film prequel. So we are going to return all the free film prequels, right? Or this is kind of what the join is saying. But let's take a look at our join condition, because this is where it gets interesting. So on the prequel ID equals the prequel film ID. So, if it has a prequel, this is fine. But then they add this or, and they say, or the prequel ID is null. And by saying that, we end up getting the whole thing. Films with prequels and films without prequels. So that one's true. And that one I, to be frank, this one to me is super, super. It's so impractical that it's kind of like, So, that one you should know. Conditions and filters. So that one's true. We demoed that one just barely. That one is true. MySQL manages a self-join between two copies of the same table through a primary key and foreign key column in the same table, and that is true. Okay, so examining the following.
Really quick, back to the last one. It doesn't have to be a primary key and a foreign key column. It can be any column. Right,
and the key word here is manage. Okay. And that's because if you can have anything set up, but the minute that you manage it, the minute that MySQL knows about it, or it is then managed, MySQL manages it. The minute it's managed, it has been defined. And the minute it's defined, it's through the primary key and foreign key, so on and so forth. Okay. So that's kind of the key word. And like I said, a lot of these questions, we were all kind of, like kind of there. So it's kind of, that's kind of where we're at. I'm just kind of explaining where it comes from, because most of the questions are correct. They're just, they just weren't covered well by the material, if that makes sense. So I'm going to try to fill you in here, but just know that you're not going to get like dock points for it or anything. So,
Thank you.
So because you are right. You can join on anything. You can put whatever you want in the join conditions, but if it's managed, it's on a primary key foreign key combination. And I think what they're trying to get at there is a foreign key, because even though it's in the same table, because I myself even used that to describe a primary key, foreign key. The foreign key is foreign to that table. Well, in the case of a self join, the foreign key isn't necessarily foreign to the table. In fact, it's more at home than ever, but it is duplicate data, in a sense, not necessarily duplicate, but so I think that's where they're trying to get at is, even though it says foreign, it's still part of the same table. Okay. Examining the following query, which type of pre-ANSI SQL 92 join is it? So in ANSI SQL 89, what kind of join is this? This is an inner join, because we did our join just like we showed. We start here with a full cross join, Cartesian product. But then we filter out only to the ones that match. So that's why it's an inner join. All right, and examining the following query, which type of ANSI SQL 92 join is it using? this one with just the plain join, if we don't have a match condition anywhere, it ends up being a cross join. Between two tables to find the data dictionaries. MySQL joins. MySQL supports. Okay, MySQL supports joins between two tables defined in the data dictionary. True. That's just two tables. All tables are defined in the data dictionary. Which of the following require resolution of a join comparison in an on subclause of the from clause in MySQL? Inner, left, right. And yeah, I think that's it. Let's see how we did.
Sorry. Okay, so let's talk about this one really quick.
Yep.
In an on subclause, so the
Sorry, did I lose you or are you still thinking?
can
Hope I
you go
missed
back to the question?
Yeah, oh yeah, sorry.
That's okay.
Oh, and it jumbled them all up.
Oh, that's fine. That's fine.
Here it is.
Oh, it was the, oh, yep, there it is. The on subclass. So a join comparison in an on subclass of the from clause. So the from clause is where you use the Cartesian.
Yeah, well, so the from clause, and technically, because, you know, if we were formatting, like if we were going back to this query, for example, the from clause, this is all part of the from clause, technically.
Okay.
The from clause deals with everywhere we get our data. So like if I were going to format this so it made sense as to order of operations, all of this is technically part of the from clause. Because it's where we're getting all of our data from. We're getting it from film. We're getting it from film actor. We're getting it from actor. We just happen to define how we connect that all in there, which is, if we go back and look at ANSI 89, it kind of makes a little bit more sense, right? You know, because it's all right there. The difference is in ANSI 92, we have to, if we're doing joins that specify matches, we define that as part of the from clause. So like if I were going to format this, it would be something like this. You know, we could say where ... If that makes more sense, because technically that's all considered from clause.
Okay.
So yeah, that one, and that one is worded again, like I will completely agree with you. It's the sentence, which of the following require resolution of a join comparison in an on subclause of the from clause in my, you know, it's just very, just keeps going. Just a sentence that keeps on giving.
Is it basically just asking which of these kinds of joins need to have an on filter, basically?
Exactly.
Okay, so a cross join does not use one, or a full join, or so a regular. So on those answers, sorry, my dog.
Oh, you're good.
Right when I unmute, I'm sorry. The inner join. Oh, sorry. On those answers, you said it's inner join, left join, and right join, because those types of joins require you to have the filter.
Yeah, because anything that really doesn't have one becomes a full join, and we don't need, really what it's asking. The easier way to kind of say, to read this is, you know, or remember it, is which ones don't need an on clause. Because if we're getting a Cartesian product, we're not matching anyways, we're multiplying. We want every possible combination. So as far as ANSI 92 and these specific joins go, you know, if we're matching, if we even care about a Venn diagram, in this case, it requires an on clause.
And then one more thing, that makes a whole lot more sense now. So we've got inner join, left join, right join, full join, and then just join. Why just the word join?
So that's
different from the others.
Yeah, so technically, so like if I wanted to get, let's just use the same thing here, f.title, and
Is it the same as a cross join when they just say join
Yes.
for syntax purposes? Okay.
Okay, so when they say join by itself, they mean cross join.
Yeah. Yeah, because basically this, and I guess to make it more sense, ANSI 89 consists of, let me make a bigger comment here because we're going to need it. ANSI 89, it didn't specify join types. You had to do it all manually in the where clause. So in ANSI 89, it was always either done with join or a comma, like we did earlier, and that's not gonna. So like down here, I showed you with comma just because that's what most people did, but we could have. This is the synonymous essentially. This is how you could have written this back in ANSI 89. This is our inner join comparison, but we still had to have our where clause with our where and. And similarly, this is still all part of the where clause, even though we say and. So, you could either use join or a comma, and it would still just be a cross join. And whenever we do a cross join, we're multiplying. So it doesn't, it doesn't support the on clause, but it wouldn't make any sense to support one to begin with because we are multiplying. So the whole reason we're doing a cross join, it doesn't matter. So as far as this goes, ANSI 89, you just had a join. We didn't have a way to specify it. We didn't have a way to determine what kind of join it was. But in ANSI 92, they said, hey, let's make specific join types because we're sick of writing so much in the where clause and it's inefficient. So then we came down to, we have the cross join, which is really the equivalent of join or a comma. We have an inner join.
Where does full join come in?
Where does what come in?
Where does full join come in again?
Oh, so a full join. Let's just run one just so we can show you. All right, so our full join is, let me pull up. I really like this diagram.
This is where I get lost, is all these different joins.
Yeah, and that's why I really like to keep this thing up here.
And that just wasn't in the textbook reading, right? So we
Yeah, it wasn't. But this little table here is my favorite because it kind of has it all. So you can kind of see here we have our and this one's all the 92s. So we have all of our ANSI 92 SQL joins here. We have our inner, left, right, and then our full. And our full is kind of, it's not necessarily a cross join. It's just everything. I don't care if it matches on the right. I don't care if it matches on the left. But we're also not multiplying, right? Because like if I did a full join of this one down here with my customer, and sorry, I think I actually said full join before was Cartesian product, which it's not.
So you're saying a full join is it's adding those together, where the cross join does the multiplying.
It's not necessarily adding them. It's the same thing as if you did a left join and a right join combined. Because let's say like I had customer here, and this is a bad example. Let's say that I had, this one where I take myself, right? You'll notice that I don't have anything in rental, but let's say there was a rental that didn't have a customer. I would also see a row here that had all the rental ID, but the customer ID would be null. All this would be null. So, with ANSI 92, we have an answer for everything on the left, just like we have here, where we have everything from customer, everything from the left is there, and not necessarily everything from the right. But if we wanted all of the customers and all of the rentals, whether or not they had a match either direction, we would do a full join. if that makes sense. So our full join now typically, like in most cases, like in this case, between film and film actor, we are going to have the same result as an inner join because we have all those matches. And I'm trying to think of a table. Oh, film actor, film ID. Sometimes I type what I say. Let's see, full join, film actor, from film F. Oh, and do you know why? It's because, again, MySQL doesn't support a full join. I don't think. Let's take a look. I don't think it does. Okay. Yeah, so I don't think, so MySQL doesn't support a full join, but a full join is everything, whether or not it has a match on the left or the right. And most of the time you do that just to, most of the time you do that, like let's say we wanted, and in this case, most of the time you have a primary key, foreign key set up on either end. And because most of the time your data is hierarchical, meaning that you have a parent table and a child table, just like we have film and then film actor. But sometimes you might want everything, whether or not it has a match or not, just like when we did our, where's our INERSECT, or did I delete that already? I might have deleted it. When we did our INERSECT based on full name and last name, well, what if we want everybody from customer and from actor? We want both their first names and last names. Then we would do a full join, so to speak, if it was supported. So that's kind of a weird one. You don't necessarily, so full join will get everything. And that's why I really like this, this diagram, because if we take a look at our full join, we get everything regardless of, we get everything from the left, we get everything from the right, and we get the matches. So pretty much we get all the rows lined up.
Which one of these would be the cross join?
Yeah, that's my question too.
Okay, so the cross join,
because it's like it's got some but not all.
yeah, and so let me go, because the cross join's the only one that's a little different because the Venn diagram really doesn't matter. So let me show you one here, because this is the easiest way for me to remember it. Because this is the old curriculum, and this is actually where I learned all my stuff, was on this web page. So let's take a look. So here's our cross join. So, you know, normally we show these overlapping Venn diagrams. With a cross join, it's not a Venn diagram at all. It's literally A times B, if that makes sense.
But wouldn't that be the same as a full join? Because you're getting everything from both?
Well, but this multiplies it. So for example, if on a full join, if we're trying to calculate total rows, on a full join, it would be table A plus table B, and that would be our total row count. With a cross join, it's multiplied. So it would be table A times table B. So let's just select yes, and I can. Okay. So let's do a little quick example. So if I wanted to get every combination of some dice rolls, right? So I could select, and I'm not going to do all of them. Let's say it's a 3-sided dice, right? Because I don't want to type this a million times. So if I run this, I'm going to get a list of 1, 2, 3, right? We're going to call this dice 1. Now what we're going to do is we're going to do a cross join, and we're going to take this same thing, but we're going to call it dice 2. So we're going to select Let's see, I'm going to have to give these aliases. If this was a full join, what we would get is we would get 1, 2, 3, 1, 2, 3. So we would end up with a total of, actually in this case, it would be 3 rows because they all match. But if I actually had a 4, we would get, and that's what's kind of different about the full join is you get them all. And if they match, they match. And if they don't, they still show up, I guess is the key. So it's not necessarily even addition. Select, and we want dice1 dot value and dice2 dot value from. So in this case, because we have 3 and 3, we get 9 total rows. And you'll notice that it, we can even order this. Let's order by 1, 2. So you'll notice that we're multiplying. So every time I roll a 1 on the second die, I could roll a 1, 2, or 3. If I roll a 2 on die 1, I could roll a 1, 2, and a 3, and so on and so forth. So we're multiplying. So we end up with 9 total rows. Now, I guess as an example, let me add one more here. Select 4 as value. Because now what we're doing is we're taking 3 times 4. So 3 times 4, we should end up with 12 rows. This time we'll notice that now we get 1, 2, 3, 4 for every first set of values. If this were different, and let me pull up a spreadsheet here real quick because it's not supported, which is actually, you know what? I think I can make this work. Let's just go ahead and let's do a new one here. Let's see, do we have to do this? I rarely use outer joins here. Let's see, union should work. Oh, I need an on clause. On. And this would actually be down here. This is why it's not happy. So we can show you a full outer join, the difference here. Let's just start with that. All right, so here's a good example of a full join. You'll notice that in this case, compared to our previous, where we got multiplication, in this one, we get the matches and we still get this 4. Now let's do something a little trickier here. Let's say we're going to union and we're going to select 5 as value. Now 5 doesn't exist in the other table either, but you'll notice now we can have a null in either side. Does that make more sense?
Yeah, that makes a whole lot more sense.
Yeah, this is the key, because if we did a left join, we can only have nulls in the right. If we do a right join, we can only have nulls in the left. With a full join, we can have nulls on either side. But it still matches the one that match. So
can you say that one more time? The left and right join piece?
Yeah, so if we did a left join, and let's just do it so we can see the difference. So if I do a left join, we're going to get everything from dice 1, whether or not it has a match in dice 2. So we'll still see 5 there, but we're not going to get everything from the right, meaning we're not going to see a 4. So if I run this, you'll notice the 4 goes away, but we still have a 5 because we're getting everything from here, but this may not have a value. It may be null.
Okay.
But if we swap this and we say, let's get a right join, which is just ordering, really, we want everything from the right. So now we're going to see a 4, but not a 5 over here. So we got our 4 on this side, but not a 5 on this side. So if we want to see all of it, whether or not it has a match, we do a full join.
Okay.
So, and the difference there is if we then change that to a cross join, we get the multiplication. You'll notice that I forgot to take the on clause out, and it says, hey, you have an on clause. It's not going to do anything. We don't support it. So, and once we do our cross join, we get the Cartesian product, or table A times table B. Or I like to just say every possible combination. And really that's what the cross join is nice, is if you want to like just get every possible combination, it's really useful for that. Great questions. Yeah.
That's a lot cleaner to visually understand.
Yeah. And I apologize. Usually like these are a lot easier to throw examples out, but this is my first semester teaching MySQL, and I don't use MySQL very frequently for the more complex things. And so I often forget that they don't support certain things, which becomes then a major roadblock for me. But luckily SQL Server is there to answer the call. So, so yeah, that's those different joins. And those joins are one of the hardest concepts to get when it comes to querying data. So if you're a little fuzzy on it, it's okay. You know, you're going to practice, you're going to get better. And that's fine, because it just takes, honestly, it just takes moments like this where you can see it. Cause to me, seeing an example is everything. And so, yeah.
Can you put this, these two joins, the cross join and this full left right join out there so we can copy and paste it and play with it on our side to kind of keep cementing that into our brains?
Yeah, the only problem is, like I said before, the full join is not supported on MySQL. So
What are you doing right now if you're not in MySQL?
I am in Microsoft SQL Server. So there's many different vendors of databases. The most popular in business are, I guess, SQL Server. Microsoft SQL Server is probably the number one, simply because it is highly performant. It's got great support, and it's the cheaper of the big paid databases. So to have SQL Server, you're going to have to pay for it, but you have support. It's a great product. The second one is Oracle, and Oracle is the kingpin of databases. It's the first one that was ever out there, and they kind of rule the database world, so to speak, in the sense that all the biggest databases are mostly on, lots of them are on Oracle. Because they've been around a lot. They're feature rich. You can do crazy things with Oracle that we're not going to go into, but Oracle is very good, but it's expensive. So those are the two big paid ones as far as SQL databases go. Then there's some great free ones. The two main open source ones are free ones are MySQL, the one we're using, and then the other one is Postgres. And Postgres is by far my favorite that I use, just because I spend most of my time in Microsoft SQL Server, but all my own stuff, I use Postgres because it's free, but it still has all the features. So I guess that's what I'll get to is MySQL is owned and maintained. Even though MySQL is open source, it's owned and maintained by Oracle Corporation. So, you know, this is just me speaking. Why would Oracle build a database that can compete? Why would they give away a free database that would compete with their paid product? That's why MySQL doesn't support a full outer join. That's why it doesn't support accept, intersect, and all that kind of stuff.
Like a free app.
Yeah, it's like the free version of Oracle.
Yeah, got it.
Which is why I like Postgres, because Postgres is free, but it doesn't have any ties to anyone. It's its own thing, and it is so whenever like you see like advertisements for the two, MySQL is the most used open source database. Purely, I think, because of WordPress. WordPress runs on MySQL. There's lots of WordPress sites out there. But Postgres is the most powerful open source database, and it is feature equivalent to Oracle and SQL Server. So Postgres is awesome. I like it. But more often than not, if you get out there in the world, you're going to be dealing with Microsoft SQL Server, possibly Oracle. You will probably deal with MySQL. Lots of people use MySQL for little like projects and stuff like that. Postgres is rising in popularity just because more and more people are becoming aware that, oh, I built this whole app and MySQL can't do X, Y, or Z now, and now I have to rewrite my whole database. So more people are switching to Postgres. Sorry, that was a tangent, but that's the difference. So, and I think you can play with a lot of these. I think Microsoft SQL Server you can get as a student, like an education non-commercial license for it. There's various things, but honestly, I think for the sake of this class, I don't think you're going to come across full join again. And I'm going to verify. In fact, now that I've said that, I'm going to go, as soon as this is over, I'm going to go into next week's quiz, the Proctorio one, and make sure there's no full join on there. I'm pretty sure I didn't see any because it's not covered. And the reason it's not covered is because it's not supported by MySQL. So, I mean, it's good to know, but I don't think it will be on the exam.
So about next week's exam, sorry.
Yeah.
Is it all like building on previous weeks, or is it for the current week's material?
It will be kind of a, let me see if there's, yeah, I'm going to see if I can pull up the questions again, because we'll just sample one or two of them real quick. There's nothing worse than being nervous. I know that feeling.
Well, is it more of an exam, and that's why the proctor exam, or is it just the same type of quiz, but just with being proctored next week?
Sorry, can you repeat that one more time?
I guess I was just wondering, is it more like a midterm exam where it's building on the previous weeks and now we're taking a test, or is it just like a weekly quiz but just getting proctored this time?
It's kind of a weekly quiz that's just being proctored, but you will see some stuff that's up to, if that makes sense. Very likely that you won't see, it's not going to cover as much. It really covers chapter 7 of the book.
Okay, thank you.
Yep. And yeah. And so you'll definitely want to be up to date. But yeah, its main focus is chapter 7.
And is it still no book, or can we use our book?
It is proctored. So I don't believe it is a book. Let me hurry and read. It is open book. You have 90 minutes. There we go.
Okay, so it will be open book.
It is open book.
Okay, good.
Does that mean if I'm using the digital book, it's okay if I leave my screen and go to the other?
Yes, and if you have any issues with Proctorio, like I said, this is my first time, and I actually tried to like take it, but when I do it, it says, oh, it won't work, and I don't know how to like actually test it. So I don't know how it's gonna work, to be honest. So whoever does it first, just let me know.
It would be okay, you think, to pull up the digital book.
Yes, absolutely. Yep.
Video
Yeah, because if they don't let you do that, we'll figure something out, because
I have my Kindle or something open with it. All right, we're good.
Yeah.
Okay, thank you.
Yeah,
One more random question about the ANSI 89 and 92. Is that just to inform us? Is that because we'll come across databases that still use the 89 format?
Yeah. So even in my time, because I would figure I mean, I got into this business like 10 years ago. Wow, that makes me feel old. Anyways, I feel like I'm pretty new to the scene. I mean, because I was born after ANSI 92, right? So, I feel like I'm pretty new. I still come across people who write their joins in old format. And the main reason, I'll tell you, the main reason why it's covered is because on certification exams, they cover ANSI 89 as much or more than ANSI 92. I don't know why, but when I took my Oracle SQL certification, ANSI 89 was very prevalent on there.
Okay.
Does Proctorio allow multi? Because it might not do multi-screen, but does it do multi-browser window?
It didn't let me do a multi-screen. I have my 3-screen setup. My husband's a computer guy.
My son had it last semester, and so did I. And they make you shut basically everything off. And they monitor your eyes and the whole bit, so that they want you not to be cheating off screen or looking at other screens.
So as somebody with Canvas, yeah, but you can that's all customizable. That's not set in stone for every single test ever on Proctorio. You can every teacher can change it so that you can have more tabs, have different applications, have different windows even.
Gotcha. Yeah, and I think ours is set up to be that way. So if you try it and it doesn't, let me know, because I will give you another attempt or whatever. But it should be set up that way. I'm kind of hoping maybe one of the instructors has one of their students try it first, and then we'll know. But if something happens, I will let you know. But yeah, it should be set up that way. That is good to know. All right. Yeah, so it should because it does let you. Okay, so I'm actually in there right now. It is restricted down to one screen, which I can't change, just so you know, because I'm a multi-monitor person myself. But that might be a limitation of something. Anyways, that one's locked, so I can't change that for you. But it does let you have multiple tabs. So that should be all set.
Okay, thanks. So I'm good to keep open the digital book in another tab and just go look in the chapter.
Yep.
And are we able to use like my tutorial, our W3 schools or W3 resource?
I consider those to be open book, so yes.
Okay.
So is there any resource that is not open book? With the
No,
quick search?
I don't think so. So
It's okay to go find answers. Okay.
Yep. Yeah, and I think as you've kind of noticed from a lot of the quizzes, it's not necessarily like it's not super easy to find the answers most of the time, even with Google. So, and I think that's kind of the idea. So, good questions. I'm glad you guys have brought all this up because it is good to know. So, does anyone else have anything they'd like to see or something that's super confusing? Alrighty. Well, I will let you guys go. I said it was going to be short, but we ended up going for an hour and a half anyways, but hopefully it was beneficial. So anyways, thanks everyone for coming. Thanks for your questions. They are super great. Yeah, they help me gauge where you're at, and I'm sure someone's going to benefit from the extra coverage. So if you ever have a question, feel free to ask, even if it's just on Teams, and yeah, we'll keep plugging away.
Thank you, brother.